This lecture is 11th week. We are learning chapter 5. Until next week, we'll complete this chapter 5. Before starting this lecture, let's look at this youngkim.net web page, simple web page. Here we can reach that announcement web page. I'm clicking here. I want to show then this URL. To look at that supplementary web page, after enlarging this one a little bit. Okay, this one is supplementary web page like this. And even though that is for 6th edition, this one is useful for 7th edition, even for 8th edition. Here we are referring to these interactive animations as well as video notes. And I am recommending you to refer to this one. But here about chapter 4 and 5, nothing here, thus you don't need to worry about that. Just for these contents, interactive animations for chapter 6 later, you can refer. And at that time, I will be back here again. And let's look at this video note menu. Then as we used already, chapter 1 to 3, we are now learning chapter 5, but in the 6th edition, this topic is discussed in this chapter 4. Thus today's topic about BGP, that is Border Gateway Protocol, that is introduced here. Thus you can refer to this video note. Also, you are interested in that Dijkstra's link state algorithm, then you can refer to this video notes. Those are explained by the authors. Let's look at this one first, briefly. Here.
Hi everyone, this is Keith Ross, once again broadcasting from
all
New
together,
York City.
how does an
And
entry
in this
get into
video
a
note,
router's
we are
forwarding
going
table?
to examine the question,
Then you can
how
understand
does an
better.
entry get into a router's forwarding table? And this particular video note will put together a lot of...
I'll stop here. And this one is not accessible. Interactive exercises, you cannot access this one. Instead of this one, I'll be back to the announcement web page. The link is for that interactive exercises. You can click this one, then you can access this information. This one is interactive end of chapter exercises. This one is provided by the author, mainly for 8th edition, but this one is still helpful for our 7th edition. As we learned already using this one, chapter 1 to 3, we are learning chapter 4 and 5. After midterm exam, we are learning this one. And let's go back to this chapter 4, even though those are explained already before this lecture. And you can refer to this network layer data plane interactive exercises. This one is about network address translation, and this one is about longest prefix matching and the subnet addressing and IP version 6 tunneling and encapsulation. And later I will write the recommended exercises in advance. I am announcing that 4 exercises I am recommending. And last one, you don't need to worry about that. Just the 4 exercises. I'm asking you to do that exercise by yourself. And about chapter 5, we are learning chapter 5. And this chapter 5 is about network layer, especially control plane. And here, you don't need to worry about that. All of them just for reference. And I will not ask in the quiz or final exam. Just for reference, you can refer to them. For the chapter 6, probably 13th or 14th week, we learn about this link layer, then we'll be back here. And also I will choose some of them. Okay, let's wrap up here and we'll be back to our lecture. We'll start from here. This is subchapter 5.4, routing among the ISPs. That is about border gateway protocol. Let's move to the next. For internet inter-AS routing, we are using this BGP protocol. This BGP stands for Border Gateway Protocol. Border between autonomous system network, and this one is gateway protocol for that, and this is de facto standard. As a matter of fact, this one is standard, and we are using actually in our internet infrastructure for inter-domain routing, and this one is inter-domain routing protocol. And this is like glue that holds the internet together. The internet is composed of many different kinds of network. That means heterogeneous networks. Those are tighted, those are glued tightly. Those are glued tightly using this BGP protocol. This BGP protocol provides each autonomous system a means to eBGP. E means external, and iBGP. I means internal, and I'll use that pen here. Okay. I means internal, E means external. With this one, BGP can obtain subnet reachability information from neighboring autonomous systems. And with this iBGP protocol, propagate reachability information to all autonomous system internal routers. Thus, this one will be used, this protocol can be used internally, and this one is used externally. Determine good routes to other networks based on reachability information and the policy. I will explain about this policy later. And for this BGP, this policy is also important. Allows subnet to advertise its existence to rest of internet. Thus, with this one we can advertise the network information to other network. I'm here like that. Let's go to the next one. Okay, this one is explain about eBGP protocol, iBGP protocol. In the previous slide we learned BGP protocol. There are two kinds. One is external BGP, another one is internal BGP. And here, red one, this one is eBGP connectivity. This one, and also this one. Externally, this protocol is being used. In that case, this is eBGP. And that BGP information is being used internally also, then that is iBGP, internal, here, inside. That information, reachability information, will be used to advertise or propagate to other routers to update that forwarding table. This ONC here, ONC is here. These gateway routers run both eBGP and iBGP. You can see this line. This one can be able to run this eBGP, this eBGP, and this is iBGP. Both of them. This one is running. Okay, this one is about basic concept, a little more in detail about the BGP protocol, and that is explained in the video clip as I showed you already. And after watching that video, you can understand it better. BGP session, two BGP routers exchange BGP messages over semi-permanent TCP connection. This one is using TCP connection to exchange that BGP information, exchanging that BGP messages. And advertising passes to different destination network prefixes. BGP is a pass vector protocol, and that will be explained a little bit more in detail, and also that is explained in the video clip, but I will explain again here. Advertising passes to different destination network prefixes. Network prefix means address. Think about 32-bit IP address, and the front part, MSB part, that is prefix. That is subnet address, right? That is network address. And that is, in other words, that is network prefix, because that is in front of that IP address. That is called prefix, in other words, but same. When AS3 gateway, router 3A, let's try to find the 3A. Where is that? This one, 3A. This one is autonomy system 3. This one is autonomy system 2. This one is autonomy system 1. And between them, we are using BGP. BGP is glue to connect them tightly together. When AS3 gateway, this is the gateway, router 3A. And this one is advertising pass information, AS3, and X is here. This one is the IP address, and that is called network prefix. And this one is AS3, autonomy system. Thus we need these two information in this autonomy system and this network address prefix to reach this X. And that information is advertised to AS2. This one is AS2, and especially to this 2C that is connected, because this one is gateway. That information is advertised to this one. You can reach this X IP address, but this one is subnet address, network address, or if there are many IP addresses are being used for other host computers, other nodes. Thus this one is called prefix, like subnet, IP address, network address, you can think. And this one is the 2C. This one is also gateway. This one is also gateway. This gateway is in this autonomy system 3. This gateway is in this autonomy system 2. Also this one is the gateway located in this autonomy system 1. Here AS3 premises. This one is advertising that information. That information is this one. You can reach this X network or IP address through this AS3. Then this one is promising. If you are sending some datagram that is destined to X address, then that can be reached through this gateway it will forward datagrams towards X. This one. And this one can be reached in this way or in that way, depending upon that shortest path algorithm that will be chosen. And this one is also explained in the video clips I introduced already, and that video was explained in that video. They also explained something related to this one. Okay, let's use this one. Path attributes and BGP route. Advertise prefix includes BGP attributes. Here, what is BGP attribute? BGP attribute here, we look at this one. There are two important attributes, and the prefix and the BGP attributes, and this one is being used as a root. Here, let's look at these attributes. Even though this one is explained in the video clips by author, ASPath is the list of ASs, autonomous systems, through which prefix advertisement has passed. And I'll show you that example later in next slide. Next type is the hop means router. We are jumping from here to here. We are hopping. That is hop. That is router. We are going in that way. This is called hop. Next hop means next router. This next hop or next router indicates specific internal AS router to next hop autonomous system. And that is explained already, but in next slide, if some bibliography is there, I'll show you. Let's move to the next. This policy-based routing is very important in this BGP protocol. Gateway receiving route advertisement uses import policy. Gateway receiving route advertisement uses import policy to accept decline paths. For example, never route through autonomous system Y. And I will explain a little bit more with analogous example. Okay, here AS policy also determines whether to advertise path to, okay, I will use this pen, advertise path to other, okay, twice here, you can eliminate one, erase one, other neighboring autonomous systems. Policy is like this. Okay, think about our North Korea and South Korea here. If we want to go directly through this border, then that will be the shortest path. But it is not possible depending upon the policy. If policy is accepting and approving that, then we can go there directly. But if policy is not accepting that, instead some other detour is recommended, then we should use that, depending upon the policy, even though that is long distance and further distance than this. The policy is more important in our real situation. In our computer network also, that is important. And this, depending upon that import policy, if the policy is like this, never route through autonomous system Y, then we cannot go through that. For security issue or for many other reasons, we can decide that policy. Thus, this one is done by this policy-based routing. Okay, this one is explaining about a little more in detail BGP pass advertisement. Here, autonomous system 2, this one is autonomous system 2 as we observed already in the previous slide, same. Router 2C, this is gateway router. This one is receiving pass advertisement, and that advertisement was done in the previous slide also, same. A3 and X. Thus, that means X can be reached through this autonomous system 3, and this one is accepted, and that will be guaranteed to deliver. And this one will forward. 3A is doing that promise. Via eBGP, that information was given here from AS3 router 3A. This is called, in other words, gateway. And that information should be distributed to other internal nodes in this autonomous system 2. Based on AS2 policy, AS2 router 2C here accept pass AS3 X and propagate. When this one is propagating that information internally, then this one is using iBGP. That is BGP information, BGP message from this one. And internally that will be distributed, propagated. Then this one is using iBGP to all autonomous system 2 routers. This one, and this one. That will be advertised to that and propagated to that. Based on AS2 policy, also always the policy is in more higher priority. Thus that will be checked first. AS2 router 2A advertises. This one is advertising depending upon that policy, and the policy is approving and accepting that. And that information is given to this 1C gateway of this autonomous system 1. And in this case, the protocol to send to here, that is eBGP here. Pass AS2, and here, this pass autonomous system pass information, AS2 through AS3, this X can be reached. This is called reachability information. And that will be given to this 1C in this autonomous system 1. Let's look at this one. This one is using the same network, but this one is showing another direct link between this 1C and 3A to connect autonomous system 1 and autonomous system 3. In the previous slide, this one was not there. Let's go back here. But to show and to introduce another explanation, this direct line is shown here. Let's assume this direct line is there. Then let's look at this one using this pen. Gateway router may learn about multiple passes. Sometimes this gateway may learn about multiple passes to destination. Destination is X. And AS1 gateway router 1C, this one is learning about that pass AS2 through AS3 X that was given from this, because that is propagate to this, and that is another gateway here, and that information is given to this. If parties accepted, then that will be given. If that is approved. Okay, this one, we are looking at this one. From 2A, and that is given one pass. Then this one can be used like that. And another one, that information was given from this 3A gateway of the autonomous system 3, AS3X, that reachability information is given using the external BGP protocol. In this case, as we learned already, eBGP protocol. Then, based on policy, AS1 gateway router 1C chooses, there are two paths, right, to go there. Two reachability information, one here, another one here. Then which one will be chosen? Depending upon that policy, this one will choose. 1C chooses both AS3X and advertised path within AS1 via iBGP. Even though there is another reachability information here, that will not be propagated to other internal routers in this autonomous system 1, because this one is deciding. This one is better if that is considered as better path, because that is going through only single link, but this one is dropping by this another autonomous system, but this one is using direct line, direct link. Then that will be better, because that information is propagated using this iBGP in this autonomous system 1 by this 1C gateway router. Okay, BGP messages that is explained here. BGP message is exchanged between peers over TCP connection. Okay, I'll use this pen. To exchange that message, we need some protocol, and BGP is using TCP connection, using TCP protocol. And BGP messages there are four kinds here. Open message for opening TCP connection to remote BGP peer and authenticates sending BGP peer. And update message for advertising new paths, or sometimes you withdraw old one. And also another one, keep alive, keeps connection. With this one, it is keeping that connection alive in absence of updates, also acknowledgements, open request. Another message, notification. This one is mainly for reporting errors in previous message, also used to close connection. And this BGP and OSPF, this one is internal, exterior, interior. This one is exterior, outside, external protocol. This one is interior. Internally, this one will be used. There are two kinds, as we learned already. This one is inter. This one is interior, internally, internal. Routing information protocol, all kinds of them. Okay, this BGP is in inter gateway protocol, and this OSPF is interior, internal gateway protocol, as we learned already. And how the porting table can be updated, this one is explaining. And also this one is explained in detail in the video notes, as I showed you already in the supplementary web page. The question is, how does router set porting table entry to distant prefix? And this destination network address, that is called prefix. And this one is interface here. 1. Okay, let's look at this one first. Okay, local link interfaces at 1A, there is 1, 2, and also on D, there is 2, 1, 2, and the interface port number, physical interface. And recall 1A, 1B, 1C. Here, 1A, 1B, 1C. Those are learning about destination X. X is here. Via IBGP from on C, as we learned already in the previous slide. This one is continuing that explanation with more information to explain a little more. Path to X goes through 1C. This one is advertised and propagated. That means this 1C gateway, this one will deliver port to this one, to this X. 1D, this one is 1D here. OSPF intra-domain routing to get to 1C and port over outgoing local interface 1. Thus, to send some datagram, and this one got that information already propagated, and this one is showing one example how this one is sending into that information. And this information already given, and X1, that means X, this destination network address or prefix, that can be reached with this reachability information. Then this datagram should go out instead of this 1. There are 2 links, 1 and 2 interface port number. There's one will be chosen. Then this one will deliver like this. Internally, if there is another, let's assume there is another link here, then internally, when this one is choosing this path or this path, depending upon that the OSPF, this one will choose the shortest path. That's the interior gateway protocol. And this entry, okay, another question here. Okay, let's look at this pen, the color, and let's use this one. How does a router set porting table entry to distant prefix? Let's assume there was nothing about that entry, and that was put in here. And this one is explained here in this way. Recall 1A, 1B, 1C. This one is explaining about that. 1A, 1B, 1C. As in the previous slide, learn about destination X via IBGP from 1C. We learned already. And path to X goes through 1C. Here, 1D, here. OSPF intra-domain routing to get to 1C and port over outgoing local interface 1, as we learned already, and that will go out. 1A here, 1A. not this one. On this here, and on A here. Let's focus on this one, in this one. On A, OSPF intra-domain routing to get to 1C. This one is explain about how this intra or interior gateway protocol OSPF is being used internally. The datagram can be sent in this route or in this route. Depending upon the OSPF result, that will be decided. And if that is shortest path and algorithm decided that, then this link number 2 will be used to send out that datagram. Thus this one will be updated like that. People that is found. People that was found. That by the algorithm, this is the shortest path. Then this one will be updated. And this entry is created. Okay, this one is explain about the BGP route selection. Router may learn about more than one route. Okay, I'll use this pen. Router may learn about more than one route to destination autonomous system. Select the route based one. And also this one is explained in the video note. Local preference value attribute based on first decision. And the shortest AS path. The AS number to go through, that number is considered, and if that number of that AS path that is smaller, then that will be chosen. Closest next hop router, and next one is closest one, then that router that will be chosen. Closest one will be chosen. That is similar like hot potato routing. And hot potato, think about hot potato, so hot. Thus from your hand to other hand as soon as possible. Thus the closest one is the next one to send. And if we have something more, then that can be considered depending upon that additional criteria. Okay, this one is explaining about the another issue, but less important, achieving policy by advertisement. Think about this. Okay, I'll use this one. Legend, this one is explained about provider network, internet service provider network, ISP. Another ISP. Another ISP. And they are customer network. Suppose an ISP only wants to route traffic to from its customer networks, does not want to carry transit traffic between other autonomous ISPs. For example, A advertises path, A is advertising, and the W customer network is attached here. Thus AW, that information is provided to this B and the C, like this. And the P is choosing not to advertise PAW to C because C is the competitor, another internet service provider. For example, this one is SKT, this one is LGU Plus. Then this one is not providing that information to this. Instead, this one will be sent to its customer directly. B gets no revenue for routing that information, that datagram through this BAW, that is Internet Service Provider, sees datagram. No responsibility and no revenue from that service. Thus, that is not considered. That thus this information, reachability information, will not be given to this. Instead, that information will be given to this. C does not learn about CBAW path. Thus, C doesn't know this information. C will root CAW not using B. Also, similarly, this one is not providing that information to B. Only that will be provided to this, what is, to its direct customer network. Okay, this one is still explaining about something more. Suppose an ISP, okay, I'll use this pen. Suppose an ISP only wants to route traffic from its customer network, does not want to carry transit traffic between other internet service providers, same like previous slide. ABC are providing network, additional explanation about that. And XWY are customer. X is dual homed. Here X is connected to two internet service providers. Thus, that is called dual homed, attached to two networks. For us to enforce, X does not want to route from B to C as a transit network via X like this. X will not advertise to B a route to C because it doesn't need to do that. It is not necessary as a customer network. Why different inter-AS routing we are using? Let's think about that policy. We learned a little bit about this. Inter-AS administrator wants control over how is traffic routed, who routes or routes through its network. Intra-AS, single administrator, so no policy decisions needed. For simplicity, one rule and apply. Then that may be simpler than considering many policies internally. Thus, this policy is important between autonomous system, different autonomous system, or different internet service provider. Okay, scale. We should think about the scale. Hierarchical routing saves table size. If we are using this hierarchical routing, then we can reduce the table size. And also we can reduce the traffic update. In terms of performance, Intra-AS can focus on performance. Internally, just performance is important to deliver the datagram internally to the destination. But Intra-AS, instead of that performance, policy will be more important. This one is dominating over performance. Okay, this is the good point to wrap up today's lecture.